Howdy folks, Mr. Reed here, and welcome to one more question. So what I'm going to be taking a look at right now is using some exponent laws to simplify an expression that's a bit clumpy. It has a lot of exponents in it, and we can make it look a lot tidier if we know how to use exponent laws. Basically, these questions are just made up little exercises in order for us to get a little bit of practice in using exponent laws. I'm going to make this one a mild level question, so I'm going to come in and only use whole number exponents with whole number simplifications. So because of that, it's a good starting point if you haven't been using these exponent laws for a while. So let's just get to it and see how it goes. So I always say this exact same thing whenever I intro into a video. I said something different. I hated it. So note to self. My apologies for having to live with my monologue afterwards. All right, now the question that we have is written as follows. So it is a clumpy mess. So this is x squared with another bracket squared y to the 6 x to the 4 all over x squared y cubed. Close the bracket, throw a 2 on the outside. Woo! All right, so there's lots going on here. It is all in whole numbers, so this should, for the exponents, so it should work out quite nicely. Now, what I'm going to choose to do is I'm going to take the x's that are up top and put them together with the other x's that are up top by using a rule that says if you have two bases that are the same, you can add the exponents. But before I do that, these exponents right here, I can simplify them even more, because there is another exponent law that says if you have some sort of exponent expression, so you have a base and an exponent that's raised to a second exponent on the outside, we can take those two exponents and multiply them together. Now 2 and 2 isn't a really good example for showing that it's different than adding, but I am definitely thinking of multiplying here. So I'm going to get 2 times 2 ends up giving us 4. So I'm going to get x to the 4, and then I am going to put that together with this one over here. So I'm actually going to erase that 4 that we just had, put it together with the 4 that's on the front thing that I simplified, and I can say they have the same base, so we add the exponents, so we get 4 plus 4 is 8. So I'm going to have x to the 8 from putting together the two red parts that are in my numerator. I'm also at the same time, because it's totally separate, it's a different base, I'm going to simplify my y expression. So I have a y that's in the numerator, and I have a y that's in the denominator. And as I can see, they have the same base, so the rule is with exponents that we can subtract the exponent. So subtracting the exponents, 6 minus 3 is going to leave us with a 3. So I have y to the 3, still over an x squared that I haven't dealt with, and still inside a bracket that has a square on the outside. Now, one of the things that you can do is you have freedom to apply the exponent laws in any order that you want, as long as you're properly identifying the exponent law. For instance, this 2 could have come inside onto all of the different pieces that are multiplied together in the numerator and the denominator, and then we could have just done another exponent laws to tidy those all up separately. I actually don't think that's the wisest way to do this question, so I'm leaving that 2 on the outside for now. I have x to the 8 divided by x squared, so I'm focusing on these two pieces right now. I'm going to say that they have the same base, so therefore I can subtract the exponents. That's going to leave me with x to the power of 6, so 8 minus 2. I also still have the y to the power of 3 there, which has a 2 kicking around outside as an exponent. So lastly, I'm going to use a rule that says if you have the multiple terms in, not terms, I guess, multiple multiplied pieces, factors, I guess I should say, multiple factors together inside of a bracket, and it's all raised to an exponent, the exponent can come in and apply on each of those individual factors. So in this case, I would get x, I should use the same color probably, x to the power of 6, now squared, and y to the power of 3, also squared. So my two pieces become both squared according to that exponent law that I just used. So we would now say that the two exponents here and the two exponents here, they can be multiplied together. So I would get x to the 6 times 2 is 12, y to the 3 times 2 is 6, and this is my final expression. So my beginning statement that I have up above, if it looks too messy over on the board, is going to become x to the 12, y to the 6. As I said, I could do this in very different orders, so if you see something you think should work, go try it out, see if you can get x to the 12 times y to the 6. If you do, things went well, and that's good. So if you found that one helpful, like, subscribe, and as always, take care, folks.